Circuit 1. The next step is self-union. Self-union. Circuit 1, cell 0. For cell 0, let's change the name and say inverter. Inverter. And view type is schematic. We open a new schematic. Last week we selected this. Yes, the same one is appeared there on the left hand side. Let's see here. NMOS and PMOS from here. NMOS click minus to make it smaller, and PMOS. I hope you remember how to select the component and drag it into the design. Something like that. PMOS. And PMOS. But PMOS should be above. Okay, should be NMOS is placed below. What is this? Right. Drains are connected to each other. Drain terminals are connected to each other. Okay, then gate terminals are connected to each other. Next, we have to apply a VD. Karmaşık, çeşitli şeyler. See, we have here VDD. Take it and drag it and put into the schematic section and connect it to the source of PMOS. Another one is ground. Ground must be connected to source of the NMOS. Okay, click on the home button on the keyboard and see the whole design on the fit on the schematic window. Okay, now there are two terminals left, right? Anyone have idea? Has idea about the name of this left terminals? The well of the MOSFET in which the transistor is fabricated, the substrate button, okay? Yes, the substrate material of the MOSFET. Okay. Now, one important rule for VLSI design, okay, especially for digital circuits, bulk terminal of the PMOS must be tied to VDD signal, the most positive voltage of the circuit. Okay. The most positive voltage. Now we have only one power supply, so VDD is the most positive, right, voltage. So VDD must be tied to bulk must be tied to VDD like this. Okay, this is very important. And bulk of the NMOS must be tied to source. If you do this, that means there is no body effect on these transistors. Okay, this is important information from bachelor's courses, electronics 1, electronic circuits. If the bulk source equals 0 somehow, that means no body effect. Do not confuse that. The input port is here and here. You can type an input port name here. Automatically it says in. Okay. In OK. We can increase the font size. 8 sometimes is not enough. Keyboard, see, now input is typed to gates. Then we have output here. Let's make this 10 instead of 8. We will see the letters are large. We did something. Now we will open the circuit in T-Spice. T-Spice line. By the way, does anyone know? Okay, this one. Voltage source, select voltage source. We have constant voltage, say 5 volts for example, right? But we have many different types of voltage sources. Constant voltage, pulse, frequency modulation source, even exponential for example. Say constant. Voltage source name. Voltage source name must be start with letter V. Okay? If you do not write V at the beginning, program automatically put a V at the beginning. For example, I type my name Ali, it's going to add V at the beginning and it will become Wali. Wali, okay? Wali. Say your name Aisha, it's going to be Wali is a power supply, VDD and ground 5 volts. Okay? It's very easy. I usually type this part by hand. Okay? You don't have to go through the insert command and procedures. Okay. The next step is, okay, input signals, for example. Input signal. Insert command, again voltage source, but now click on bit. A bit stream. Okay? A bit stream. To test the inverter. Set. I'm going to type some random bits here one. Sorry, start from the beginning first, okay? There are open windows here. See some another. You have to finish, you have to make DC operating point analysis as well. That's why this one is checked. Okay, this one is clear. Because DC operating is totally fine. Power supply, input test vector, analysis type. Now, output variables. Click on output. Which one? Transient results, right? We make this analysis. Transient analizi yaptık. Onun sonuçlarını görüntülemek istiyoruz diyor. Aynı kodda farklı analizler yaptırırsınız. It says V in, right? Add dedik. Insert command diyoruz ve close diyoruz. You see the code starting with dot, which means print. Transient analysis result, node in voltage, node out voltage on the same plot. Side, I put an announcement there, and there is a model kütüphanesi. Inside that there is you will see what you will do. Insert command, okay, say insert command. Files, include. Files, include. Here, using browse, okay, using browse. Desktop, VLSI tasarım. let me see. VLSI tasarım dersi, ödevi. Model kütüphanesi, SDN 0.25 micron CMOS model. .md file. Double click on this. You see the path of the library. I want to show you this model parameters. Just a minute. Just wait for a second. No, there is something wrong in my file. I made a mistake. Just a minute. Let's see what I forgot to put to insert also. Just a minute. Okay, here. VDD. Okay, this one is input field. This one is input. This one input. This is output. 0